Thomsen, are you online now?
Yes, hello, can you hear me?
I can, and I can see you.
Okay, thank you. And maybe I can share my screen. So, do you see my screen?
I see you at the screen, yes.
So, this is the Faroe Islands, and I'm going to speak about our renewable future. That will be the first half of my presentation. And then the second half will be on a particular project that was meant to bring us from oil to renewables.
Sounds good.
So this is where we are.
Sorry, there might be a problem with the screen.
You don't see the map?
No, not yet. Well, here we are. But we see it's the screen in the background. Yeah, now the presentation is here.
Now you can see the presentation. Okay.
Yes.
So now you see the map?
Yes, we do.
Okay. Here is where we are, the Faroe Islands, 18 small islands in the middle of the sea in the Northeast Atlantic. A nation on its own with 53,000 people, but we are within the Kingdom of Denmark. And we are blessed by renewables, wind and rain, and a little bit sun and the waves, but yet 92% of the energy is of our energy use comes from imported oil. So here is an overview of the total energy use last year. The total energy use was 3,820 gigawatt hour. Electricity is around 10% of that, 407 gigawatt hour. And it's mainly based on imported oil. And as we can see, the fishing, our fishing fleet and sea transport makes up a big chunk. But then we have the land transport vehicles, 11%. And we have oil burners for heating, 15%. And then we have power production is based mainly on oil. But we do have some hydro and some wind, and the wind is going to expand. And we are on our way to electrify all the transport vehicles and all the oil burners and all the power production. So we have a technology to change from oil to renewables. But as we are going to change from oil to renewables for transport and heating, it will require that we almost double the power production. And how are we going to do that? And that will be mainly made by wind, because we do have among world best conditions for wind energy. Most places where we can erect wind turbines, we do have over 10 meters per second average for the whole year. So wind, our future power production will mainly be based on wind energy. And we are on our way. We do have 4 small wind farms. And we just recently, this year and last year, licensed 3 bigger wind farms. So they have been committed. So we will actually triple or more than triple the wind energy within a couple of years. But as you know, wind is intermittent and it doesn't produce all the time. It just produces as the wind blows. So we need energy storages, and we do have the option to use pump storage. As you know, most of the energy storage around the world is based on pump storage, where you use excess energy from wind or solar to pump water up in a higher height, and then you can run the water down again when you have less wind or when you require more energy. So this definitely will be an option for us, and we are in the process to build a pump storage in the electrical system. But we do have other options to store energy. Storing heat is a very efficient way to store energy. And if you compare, if you take 1,000 kilos or liters of water and you use it in a pump storage, you lift it 400 meters up, or you just heat it 1 degree, that's the same energy. So it's very, very efficient to store energy as heat. And it is used worldwide. We do know the big heat storages in Denmark that connected to district heating systems. And we are going to use similar systems where we can use excess low-cost wind, probably through the heat pump, maybe from the sea where we have a constant heat in the sea, and we can produce heat for all our houses, but we can also connect heat storages. So we have the option to store excess wind energy as heat. There are other options, but heating, it actually is a good solution for us because the requirements for heating, it's almost perfect match between the energy we can get from the wind. We do have more than doubled energy from wind turbines in winter compared to summer, and that's exactly what we need for heating. We need more than 2 times a winter day compared to a summer day. So there's a perfect match between required heating and the energy that we can get from the wind. There are other options. We of course look into hydrogen, where we can use excess wind to split water up in oxygen and hydrogen, and we can use the hydrogen directly for buses or car transport, both on land and sea. But we are also aware of the option that we can combine the hydrogen with the nitrogen of the air, so we can produce ammonia, which can be used directly as a propulsion energy for engines. And this figure is actually very interesting for me because we can see that we do have wind and we have water and we have the air, and these are all things that we do have in our environment. It's actually prospects that we can produce our energy from all the things that we do have in our environment. So now I will switch to this small project that was part of this our journey from oil to renewables. It started as a Nordic Council project back in 2006, where we had look at this island of Nølsøy, a small island just outside Tórshavn, and we wanted to make this a renewable energy island. The Nordic Council project ran into the sand, but there were some local initiatives that wanted to carry on with this project. So there was a wind mast erected, and to get 3 years wind measurements. And then we also looked into the energy use of the houses. This is a typical house. And we can see the heating requirements. It's, as I said, much more during winter compared to summer, while whereas the electrical power is more constant through the year and much lower in energy use than the heating. So if you want to become green or use renewable energy, it's important to get the heating transform or transform from oil to renewables. So on this island, there was a second-hand wind turbine from Denmark was bought. It is a 220 kilowatt a general wind turbine that was built in the early 1990s, 30 meters tower. And according to our calculation, it should be possible to produce heat for 35 houses. So with local participants, we made the founding ourselves back in 2011, and the wind turbine were erected in late 2012. And also the water storage was built. It's a used oil tank that was put on up and down, and it was around 40 cubic meter. And if we operate between 50 and 100 degrees water, it compares to 2000 kilowatt hour storage. And cables were put into the ground, and the hot water pipes from this tank was connected to a few houses in the vicinity of this tank. And the electrical system was put up, and these are normal resistive heaters in this yellow tank, and we do have terrestrial relays that can control these heaters and switch them in and out according to the available wind energy. And here's the electrical system. There are some technical details that maybe some of you might be interested in. We do have this wind turbine, a normal induction generator to the left, and it's a 3-phase. And then on the lower, we do have these resistor heaters that can be switched in and out according to the energy. And there's a microcontroller that reads the frequency that corresponds to the speed of the wind turbine. And it controls the switches of the heaters, so to keep the wind turbine at 50 hertz. And similarly, the microcontroller reads the voltage and then switches capacitors in and out to keep the voltage steady. Now this wind turbine is meant to run on 690 volts. And here we can see to the left where we start, we release the brake, and the wind slowly turns the wind turbine, so the frequency comes up, and then it reaches 50 hertz. The heaters switch in and out and keeps it on 50 hertz. Similarly, it's an induction generator, so it should self-excite, and when the speed goes up of the wind turbine, the generator excites itself, and the voltage comes up, and we do have a lot of capacitors in to help the voltage come up. And when it reaches 690 volt, and we switch out and in the capacitor to keep it on 690 volt. And as we can see, it works reasonably well. But the problem is the start of this, because this is an induction generator, so it should self-excite itself, and that's the problem. That takes time. And this is actually the problem that we have run into. Sorry. When we have little wind, for example, 5 meters per second, we can control it, and the voltage comes up slowly, and we can control it over to the operating area of 50 hertz and 690 volts. And that is also possible for 7 meters per second. But if we reach 14 meters per second or above, our experience is that the voltage is too slow. So we don't reach this 690 volts, and then we have no option to control the wind turbine. So this actually is the problem still, that we cannot start the wind turbine when the wind is too high. We have, during the process of the development of this project, we have looked into a lot of different details. We started off with mechanical relays, but to control the wind, we need a very fast operation. And then we found some Chinese terrestrial relay that can control the capacitors, and the switch in and out the capacitor. That's not a simple task. It's actually very difficult. This project has been reported in a paper back in 2014, and if you want to see more details of this, you can read this paper from 2014. It was written together with the Professor Joseph at Aalborg University. we have been able to produce some heat, but as I said, we do have still problems with the startup of this wind turbine. So that was my quick overview of the situation in the Faroe Islands and this particular project in Nelsøy.
Thank you very much, Bjarti. It was really interesting. There might be some questions for you now, or we can also say that there's one more presentation and then we can, no, we'll have, okay, sorry. Yeah, there'll be questions for you now, and please, if anybody has questions for Bjarti Thomsen, please raise them.
I have a question for Bjarti. If I looked at your slide, you have a wind turbine of 220 kilowatt, but you're trying to control it by connecting resistors of 3 times 9 kilowatt. Does you not run into a lot of excess of power in that case? Because I understand you that you have here a isolated system where you're not connected to the local electrical grid. Is that correct? Understood?
No, you have might have missed my. If I can show you the slide again. You see my slide now?
Yes.
There's only I only show 3 times 9 kilowatt, but you see the dots, so we have many more.
Okay, then I understand it much better. Sorry,
Yeah.
sorry.
And we have experience. We started off with 250 kilowatt, a total of 250 kilowatt of heaters. And that was not enough, even if it was a 22 kilowatt in short intervals, it produced much more. And we ended up with heaters compared to 350 kilowatts. And then we could manage all the wind gusts.
Okay. Is there any possibilities to connect it to the local power grid, and or is it too weak in general?
Well, yeah, of course, we have tried different solutions to get it up running more constantly. And one of the solutions was a meeting with the utility company that have the grid in the vicinity. But that was a very expensive system. We had to buy a transformer from our 690 volt up to 10 kilowatt line. And we were not sure if they were very precaution. They said if there's any disturbance, we have to disconnect you, and it was so we didn't think that was a way forward.
Yeah. Okay. So it was a general animosity from the NAV, or what it's called. Yes. Yeah. Okay. Thank you.
Yes, and there's pardon?
Yes, morning.
Alexander, yes.
I have a question. What happened when the wind turbine is out to service because maintenance or any outage for any reason? What happened with the heat water storage with the community, and how many days the storage can be supplied, the demand?
Yeah, that's correct. We do have this water storage of 40 cubic meter, and that is to actually take out of all the variation in the wind. And if we have wind that we have no wind for say 3 days, then the water tank will be too cold, and then we need some sort of backup system that could either be a oil burner that we use before, or it could be a heat pump that is run from the mains from the utility.
Okay, thank you.
Thank you.